Well, we're about to get started. Hello, everyone. Welcome, welcome, welcome. Thank you for coming to this session. This is going to be a session all about C++. So thank you for joining us today in the room or online. If you're going to join later. This session is for you if you're coming from an older version of Visual Studio and you're considering upgrading to 2017, or even if you're using 2017 today and want to learn everything that is new with the latest update we announced this week, 15.7. Or this session is for you if you're a C++ developer and never used Visual Studio before and would like to get started today. My name is Marian, and I am the program manager lead for the C++ team at Microsoft. And we'll walk today through the 7 reasons why you should move to 2017. This is going to be a lot of content, and I'm going to go kind of in a fast pace through it. So if you don't have any clarifying questions that you'd like me to answer, please look me up on Twitter, ask me any questions. If you want a more private medium, that's my handle at Microsoft.com as well for email. So for the next 45 minutes, we'll talk about what's new in the MSVC compiler and libraries, how easy it is to upgrade to 2017. We'll have some demos about our cross-platform story, as well as we're going to dive deeper into the improvements in performance we made and the past updates, as well as the boost of productivity that you're getting by upgrading to the latest version. So there's a lot of content to be covered because really, when last time we shipped the RTW release was in March, and since then we had more than 7 updates coming in. The 15.8 Preview 1 is also out today with a lot more features that we look for your feedback in. So not everything fit into this presentation. And if there are features that I'm not going to talk about today that I talked last year at Build in the session that is named the same as the session today. And while that session is not a prerequisite for this one, I do recommend you check it out because those features that are in there are also cool and are still in the product today. As you can see, we've been busy at the beginning of this year as well with already 3 updates. And there's also something else that happened in 2018 that I'd like to quickly talk about. Visual C++ is 25 years. And right now, I want to take you through a quick journey over the history. And we're going to go back, we're going to go back, we're going to keep going back all the way to 1993. Because what I have for you is a small clip from the Visual C++ 1.0 launch. So enjoy.
Okay, there you go. A full-featured, really professional C++ Windows application in minutes. Ladies and gentlemen, that was Visual C++.
Number 1, cool T-shirt. We like it so much that we actually reprinted it, and we're handing it over at the booth. So if you didn't get yours, please stop by. We still have a few of them left. Number 2, how many of you noticed the orchestra behind Mr. Dennis Gilbert over there? Yeah, that's the kind of backup support that I would take for any of my presentations in the future. But on a more serious note, Visual C++ 1.0 really, and the subsequent releases, really change the dev world and change the perception of how we define productivity for C++ development. It's impressive and humbling to go back to the history and look at the technical challenges that the teams had to solve over the years that are things that right now we kind of take for granted, that they're ubiquitous in our day-to-day job. For example, 32-bit compilers. For example, MFC class wizard, or even like the C++ IntelliSense and debugging visualizers for STL containers. Those are things that we use every day. Those are challenging things to be done at the time. And all I can say is that I want to move on to the future, and we're really excited about the next 25 years. But for now, all I'll say is happy birthday, Visual C++. You haven't aged a bit. All right, there is one thing in our 25-year history that we were never able to claim. Any guesses what that is? There's something, yes, that we're never able to claim until this week. So we're announcing today that we have added C++ 11, 14, 17 compiler features, and we also have the most complete C++ 17 library implementation in the market. So with that, Visual Studio achieves C++ standards conformance. This has been one of our top priorities for the past 6 years and has been a huge engineering effort, including the rejuvenation of our compiler and actually making it possible to implement some of the features like two-phase name lookup, like expressions fine, return type deduction. Those are things that I'm really proud of the engineering team back in Redmond has been working day in and day out for the past 6 years. So can we give them a round of applause? Thank you, Redmond team. All right, and I said this has been our top priority for the past 6 years. I need to clarify that our top priorities will not change in the future. So we're still committed. There's always new C++ standards to be added. There's areas to improve and then bugs to be fixed. So we'll continue working on this. And that gets us to our first reason why you should be using Visual Studio 2017. That's kind of an obvious one, because you can write modern, portable C++ code. C++ Visual Studio 2017 update 15.7 is the one that has all these features that we've been talking about in C++ 17. And I want to take a brief moment to talk a bit about the switches that enable conformance. So really quickly, permissive minus is a less permissive mode. Behind it, it enables some of the functionality that could be really breaking for code bases that have been written in the past with our more relaxed implementation of our compiler. So for example, two-phase name lookup will be behind the switch. The reason why we created permissive minus is to allow large companies or open source projects to get used to with our progress on conformance, and while still migrate to the latest compiler, adopt the full set of conformance feature at their own pace. So if you start a project today, absolutely throw in permissive minus, and that's what you should start with, and that's what all our C++ project templates inside Visual Studio start with today. But if you're moving from a large code base, this could take a while because there's a lot of things that you'll need to be a lot more precise in the way you write your code. I won't go into the details of the switches. They're kind of obvious what they actually do. But the theme of the slide is that you can adopt the standard at your own pace. C++ 14 is the default now in our IDE. But if you want to take advantage of C++ 17 and you feel ready, just change the switch to C++ 17. And if you want to move to all the experimental features that we're working on technical specifications, throw in the latest. If you want to learn more about how to modernize your code, please, I hope you didn't miss actually Herb's talk yesterday. If you did, and you haven't mastered the time travel skills, the recording will be soon available. He went into more details of how to actually modernize your code. And it's not only about standardization, I should say. We do have C++ core guidelines helpers inside Visual Studio as well. The guideline support library, as well as the core checkers, which is a technology based on our core static analysis tools. They'll allow you to write more modern code. I won't go into the details today. I went through a lot more details last year. So again, please check out my talk from last year. Conformance should not be the only reason why you use the MSVC toolset for targeting Windows. You can, the toolset brings improved diagnostics, superior performance, and reliability, faster build throughput that I'll talk a bit later in another slide, as well as security tools required to build more Windows applications. For example, if you just recompile your code in Visual Studio 2017, a lot of new optimizations are going to kick in. They will give you around 9% performance improvement in your runtime code. And also, I have a list of security tools that you should use at every step of your development cycle. But I'll make a special mention of QSpectre, which is MSVC aid in helping you mitigate the Spectre vulnerabilities. that were announced, I'm sure you all know about it. If you're concerned about how you'll acquire these tools, don't be. Rest assured that Visual Studio 2017 comes with a fully revamped acquisition experience that enables you in less than 12 minutes to install everything you need to get started with C++ development. And you don't need any bloatware, any additional workloads or languages that you don't actively use. In addition to the desktop workload, we have 3 more workloads. We have the mobile workload, Linux, and game workloads. So you can customize your installation to your heart's content. Of course, you can add the C# and any other workload as well. And something that I want to call out is that in addition to the release channel, where we kind of go out with a final release every 2 and 3 months, if history is any indication, we haven't committed to that timeline in any way. In addition to that, there's also a preview channel where we push updates a lot more often. And these are the features that are still being developed. And this is your opportunity to give us the feedback and actually affect the direction that the team is taking. So I encourage you to install Preview as well if you have a chance. It works side by side with your with the release installation, so it shouldn't affect it at all. And now, the 4th reason to use Visual Studio is pain-free upgrades. We definitely want to make sure that if you're coming from 2015, there's a very easy migration to 2017. So if for one reason you still need to use the 2015 MSVC toolset to compile your binaries, you can do that by installing 2017 and adding your 2015 toolset that is pre-packaged inside the installation. Even if you're on a 2017 toolset, you can also have the option to stay behind with an older version of an update. We're always going to try to push you forward to the latest update as we iterate over the compiler, but for some companies, that may not be an option. You want stability. So you can always opt in with any of the specific update versions of our compiler. And when you're ready to move to the latest compiler, keep in mind that you also have the compiler switches to enable conformance that you can basically pay as you play. You can enable more and more of the conformance features, like the permissive minus, std C++ 17, as I was mentioning earlier. The biggest problem we have that we hear from customers when they upgrade is the fact that they have third-party library dependencies that are built with an older version. And that's what's keeping them hostage on 2015. So what we enabled in 2017 for the first time ever is binary compatibility with the 2015 runtime. What this means is that the third-party libraries that you depend on can stay in 2015 until they also migrate to 2017, but your code base can move today to 2017, and when you link it together, it will just work. Now, you can do that for open source libraries as well, if you already have them compiled with 2015, but there's a better option. We released 2 years ago VC Package, which is an open source library manager that allows you to acquire up to 900 libraries, I think we're at right now. And this is the way you can abstract away all the complexities that the open source libraries build system have and consume those libraries in a very consistent manner inside your project. So you don't have to worry about you migrating them from version to version. All right, so now we're going to switch gears a bit. And we're going to talk, we talked about MSVC compiler, we talked about the libraries and how that's the best choice for Windows. But not everybody targets Windows, and not everybody uses MSVC compiler. And that's OK, because if you are in that group, we still want you to use Visual Studio. And here's why. What's unique about Visual Studio is that from a single instance of our IDE, through local builds, cross-compilations, or remote builds, you can target all the platforms that you need. You don't have to go to a different operating system to target that operating system. Everything is done for you inside the comfort of the Visual Studio IDE. And it's really easy to get started. We wanted to make sure that people that are coming, that are bringing their code bases inside Visual Studio, don't have to move to MS Build, don't have to create surrogate solutions in projects. And they can just bring in their CMake projects. They can just point into a folder, and Visual Studio picks up all that information and makes it work. And what does it mean making it work? Enabling all the rich C++ functionality that you're familiar in Visual Studio. Debugging, IntelliSense, browsing, all those features are available even though you're not using MS Build projects. And an important note, it's not only about taking advantage of the Visual Studio productivity that we want to offer. It's also taking advantage of the tools that you use in your day-to-day job inside Visual Studio. So that's something that we're working on enabling more and more. If you use a different compiler, you should have a great experience inside Visual Studio. If you're using any unit test framework out there, you should still be using it from Visual Studio. And recently, we added support for alternative formatting solutions like Clang format as well. And I'll demo that in a bit. But before I do want to talk about another announcement that we made this month that it's pertaining to this topic. VC Package, which is the package manager that I was mentioning earlier, is now available for Linux and for Mac. So this means that you can acquire all C++ libraries in a consistent manner. And from the day one when we announced support for Linux and Mac, we have 350 libraries already available. And to put things in perspective, 2 years ago when we actually announced VC Package for Windows, we only had 20. And that's a testament of the community contributions that we've been getting over the years into this library. It was an amazing effort, and I thank you, the community that has been adding all this library in. It makes it as simple as doing VC Package install library name, and you don't have to worry about all the details of consuming those libraries. And you can learn more on that page over there, but let me actually show you. OK, so what I have here, I'll just bring in this Visual Studio Chrome, and I'll go to open a CMake project that I have. It's a sample. SFML sample called Pong. And when I open CMake list.txt from the open menu, you'll see that this is a simple like CMake list.txt that has a dependency on SFML. And it just creates an executable target called Pong. And this is the source code of that game. And now I have two options, really. One option is to go and download the SFML library binaries that someone built somewhere on the internet, sure. Or I can learn how to build it from source. I don't have to do neither because SFML is available in the VC Package library. And what I did here is run VC Package install SFML. Of course, there was a much longer spew of actually building it. Now I'm saving you the time. I'm just showing you the output. And then the next step was VC Package integrate install. What this does is connects VC Package with all the Visual Studio installations on the machine for MS Build projects. But VC Package comes also with support for CMake projects. So all I need to add is this command line switch to my CMake invocation. Now, Visual Studio invokes CMake automatically. That's the support we build in for cross-platform development. So I'm just going to go to the CMake menu and do change CMake settings. I'll just close this to make it bigger. And as you can see, I already added this CMake setting over here. So if I make a dummy change and I rebuild it, we should see the output refreshing. Actually, let me do this. Generate cache. Just to show you the SFML library, it's really coming from the package include folder. And that's all I had to do to actually consume the SFML library. Now, if I go to CMake and do build all, my project actually builds. So you can see that it's generating me a binary, and I'm ready to debug it. So to debug it, I know for a fact that this is not going to work because it needs to load some resources. So in addition to just hitting F5, I will need to set the working directory of the debugging session to be my workspace there. So the way I'll do it, I'll just right-click here, debug and launch settings, and I can change the settings for my target that I want to debug. And I'll just add current directory, workspace root. Now if I hit F5, the game will start. And while I was practicing for this, I probably should have practiced more. I played a lot more, and I was never able to win. So we're not going to try that today. What we are going to try today is actually make this work on Linux. So what I have here is a VM that I also installed VC package on. And as you can see, I run the same exact commands that I run on Windows. I run VC package install SFML, and then this just shows me all the dependencies of SFML that VC package brought in. I didn't have to worry about that at all. And then I ran VC package integrate install just to get the CMake command. But what this does on Linux is configures VC package to be recognized by VS Code, so that your VS Code instance, if you have it installed on Linux, can pick up all the headers. So what I need really for my CMake project is to take this CMake toolchain file again, which has a Linux configuration, and go back to my CMake and do, again, change settings. Scroll down to the Linux configuration and add this line over here. I'm going to switch to the Linux debug configuration now. And you can see that what Visual Studio does, copies the file remotely to my Linux machine, my project files. It runs a configure, and it already found SFML in my remote VC package folder because I told it to with my CMake file. And now I can say that I'm also ready to build it. So let's run CMake build all. Let's see if it builds. Right, and I have a binary. Now, I know for a fact, again, that this binary is not going to run on Linux because we need to specify which display it should go to because it's a UI representation. So what I'll do is go to my remote machine and find out the number of the display, which is 0. So now I'm going to go configure the debug session to take advantage of that information. So I'm going to go again, and I'm going to configure the Pong Linux CMake target now for debugging. So you're going to see a new entry here. Yes, I do want to reload. In addition to the Windows configuration, now I have a Linux debug configuration. And I just need to change the debug command. So I'll do export display equals 0. And this is how in Linux, basically, you pass on additional environment variables to the process you launch. So that's the process I'm launching, debugger command. So if I hit Frun, you see it running over here. And just to prove that this is working, I'm not going to search for you win. I'm going to search for you lose. And we're going to see that this is actually, get out of there. Phew, I lost. That this is a real debugging session. Now, if I really want to explore and evolve this sample, I do want also IntelliSense. And you can see that I have some squiggles of the SFML library here. Now, this is something that happens in Windows as well. If you go behind Visual Studio's back and do some changes, install some libraries, change some environment variables, it will take some time for Visual Studio to refresh. We have a background task that goes once in a while and checks for changes in the system. And if you want to rush it, if you know you made something that is not Visual Studio is not aware, you can go to project and do rescan solution, and that refreshes the environment. Now, what we did in the update that's coming, 15.8, so the future update, is that when you do this rescan solution, we actually made it work for Linux as well. So what happens now is if I click here, you can see that we have a manager that will go remotely and scan all the files from the Linux machine. And it will bring any changes that happen in the remote environment into the IntelliSense engine. So you'll notice as soon as it's done syncing all the folders, so it already has a cache locally, so really it only needs to bring some of the files that I added with SFML. But this is incremental. Watch it. IntelliSense is refreshing, and the squiggles are gone. That's all I had to do. So now I have full IntelliSense. If I do Control-click here, you can see I can go to the render definition window. And if you look at the path, it's really coming from my VC package installed x86, x64 Linux environment. All right. So now this is how you take advantage of all the productivity features inside Visual Studio. You've seen I did some very few changes, and I made it work both on Linux and on Windows, and I'm all set up to have IntelliSense. But as I mentioned earlier, it's not only about using the best feature of Visual Studio for you to be productive when you're doing cross-platform development. It's also reusing the existing tools that you're already using. So for example, unit test frameworks, compilers, and formatting tools. That's the one I was missing. As well inside Visual Studio without being productive, without having to drop on the command line to use all those tools. And that's particularly important, especially when you're working in a larger project, when you're working in a larger team and there are requirements around the processes of managing cross-platform development. So to do that, to show you that, I will switch to a larger project that I have here called Bullet 3. And this is a physics library, open source library available. And my virtual team tasked me to investigate a test. This is the test in question over here. It supposedly fails. So now this is a C-test. The way I would do it, I would probably figure out what is the command line to launch C-test, run it and debug it in Visual Studio, because as you've seen, it works to debug processes. But I don't have to do that. With Visual Studio, I can see all the tests in Test Explorer over there, and I can run them from there without having to interrupt my workflow. So if I'm going to click Run All to see if there's any other test potentially failing other than this one. This one might fail. And Visual Studio will run it in the background. And while we run that, let's get more familiar with this particular test. So I hit go to definition in this one call that seems to be the most important one. And I already see that it brings in another CPP file in this CMake target. This was not very evident. OK, now the tests are running. This is not very evident when I was looking at the disk view of this CMake target. There was just one CPP file there, main.cpp. And now what I need to do is maybe go to the CMake list.txt and see what other CPP file it brings to understand what's going on with my test. Well, not anymore. In 15.7, we added a new CMake targets view that allows you to get all the information you need about the CMake targets for all the CMake projects you have in your solution. So if I switch, for the project that I have here, you can see the full list of targets. The active target here in the debug target is also bolded here, just like you're familiar with Solutions in Projects view. And if I expand it, I get a lot more information about what's going on in my target. First of all, I can see all the references that are being brought in. It's more than just the files. The files are also listed here. And yes, there's a lot more files being brought in here, even the one that I was opening here. And I can do a lot more operations for each target. If I right-click on the target, I can individually build it, rebuild it. And in 15.7, we already also added support for code analysis. So you can invoke our C++ code analysis directly on a specific CMake target. And if I'm on a single file, we also enable compile file. You don't have to build the whole target or build the whole project. If you want to iterate really fast, just single file compile. And you'll get the results, and then you can move forward. Eventually, you're going to do a full build, but you don't have to do it at first. All right, so switching gears for a bit, you can see that one of the tests failed, and that's the one that I was expected to investigate. And let's see the description over here. It says that the duration has to be more than 4, and it actually takes only 2 seconds. I know exactly how I'm going to fix this. All right, so stop right there. Let me explain what just happened. So Visual Studio does automatic formatting. And when I do a close curly or I do a semicolon, it will turn on automatic formatting. Visual Studio also realized that in my project over here, I have a Clang format file. And it's telling me, hey, I'm about to do formatting, automatic formatting, honoring the Clang format settings you have in your file. And now you may ask, why do we warn? Well, because we found that there's a lot of people that have been having Clang format files in their folder for the past 20 years, maybe not 20, and they've been ignoring them just like Visual Studio does ignore them for the past many, many years. So now that we're actually changing the default behavior, we want to make sure that we warn you that we're going to use different settings. But if you don't like them, you can go to Tools Options by clicking that link, and you can disable Clang format and go back to the previous behavior. Or you can even tweak it further. You can do Clang format only on manually invoked formatting operations, not automatic. And if you're on the opposite end of the spectrum and you love Clang format and you want to use Clang format even when you don't have Clang format files in your project, just change to one of the default built-in formatting styles that Clang format comes with. OK, so now let's go back to me typing and fixing this test. So what's going on here? I see a squiggle, and it's not a red squiggle. It's a purple squiggle. And what it tells me is that, hey, I know you're developing for Windows right now, but you happen to have also a Linux configuration configured here. And what happens with the Linux configuration is that sleep doesn't work. I talk with a lot of developers that do cross-platform development, and I hear the most interesting ways that they make their team validate cross-platform development. There's always people that forget to build for the different platforms, and there's a heavy process to get them to build for the other processes. Well, you don't need to do that. Visual Studio helps you by bringing the information inside your editor. So now that even Visual Studio complains about this fix, maybe I'm going to reevaluate my life choices, and I'm going to make a better fix. So let's delete this for now. And I think the right fix here is that this should take less than 4 seconds, not more. I think that is what the intention of the author was. So now you see something else here. I don't have to use Test Explorer all the time to be able to run my tests. We brought in the information of the test runs inside your editor such that you can easily run and debug those tests. So I can do run now, and the test should now complete. It will rebuild. It will run the target. It will bring in the information back into my editor. All right. So in this demo, you've seen me start from a very basic sample and configure it running both on Windows and Linux. And you also see me work with the tools of choice that developers have when they do cross-platform development. Google Test. We also have support for Boost Test and Test Explorer. Clang format is integrated. For CMake, you can use Ninja. You can use Makefile build system as generators. And there's a lot more support coming soon as well. So now I can switch to the slides. And really quickly, these are summary slides, so I'm going to go really fast. This is kind of the stuff that I already showed you. The theme is that we want to make sure that Visual Studio open folder experience that we have added in 2017 is the entry point for every cross-platform developer that comes and uses Visual Studio. It's easy to configure and enables you to have a very familiar experience with Visual Studio. And if you want to see some demos that are non-CMake for open folder, which is completely supported scenario, you should, again, go back in time at 9:30 this morning and check Mark and Will's demos. For CMake, again, this is the most popular C++ cross-platform build system out there. And we have built this experience on top of OpenFolder because we believe that is the right entry point for everybody who's doing cross-platform development. And we keep adding features to CMake to make it as seamless as possible for you to be productive inside Visual Studio. And as you've seen, it's very simple once you are started inside Visual Studio to target Linux. The requirements on the remote machine that you have are very slim. You just need to have an SSH, really, and a building environment set up on that machine. And as you're getting set up, you can use, if your projects are coming from Windows and they have MS Build projects, you can use MS Build to target Linux. And if you already have cross-platform projects like CMake or Make, of course you can use, again, Linux, as you've seen in my demo. And I also mentioned that in 15.8, the support for remote IntelliSense based on your project settings is coming. So that is basically our goal, to make the Linux targeting inside Visual Studio as easy as it is to target Windows. And speaking of productivity, what we're going to be doing next is dive deeper into that. But we cannot start with productivity. We have to talk about performance. Because the goal of Visual Studio is to get out of the way as soon as possible. And then as you're in the inner loop of editing, building, and debugging, get out of the way again and respond as fast as we can to the actions that you're taking. And I think we believe that we're achieving this with Visual Studio 2017, more so than in any other previous release. So as you can see here, for C++ project load that it's got 4,000 projects, we already have cut the time of loading the project and parsing the C++ code in it to build a fully grown database to provide any symbol navigation in half, in more than half, actually. So really what we're talking about is improvements of an order of magnitude higher, not just small, tiny improvements in performance. That's why we want all of you to be using 2017. Now, this gets even more exciting the second time you load a project, because now we have everything completed, and the caches are built, and it takes 20x, 21.9 more precisely, x faster than you used to do in the previous release. Now, I know what you're going to say if we were here last year. You showed us this number as well. But what I want to tell you is that this was 17x last year when I showed you. And kind of the big point is that we didn't stop there. We kept going. And we'll never stop with performance. That's the promise I'm going to make you. Memory usage is also dropped. And this gets even more exciting when we talk about debugging scenarios. So when you're doing a debugging session in 2015, you're coming dangerously close to the 4 gigabytes barrier. And there were scenarios where you weren't really able to debug. Well, we definitely fixed that, and Debug FastLink, it's vastly improved in this release to be more respectful of the memory that it consumes and be a lot faster, as you can see from the average time to hit breakpoints. Those are not the only areas that we focused on. And final references and rename refactor also seen significant improvements. And specifically, call out to the Unreal Engine community. Lots of people using Unreal Engine and giving us the feedback. Please keep that feedback coming. We love it. The improvements we made there apply to everyone else as well. So thank you. And speaking of Unreal Engine, let's talk about build throughput. So Microsoft has been has been in contact with AAA games companies in the past to better understand the build throughput requirements in a real-world code base in a real-world setting. And here I'm highlighting 2 that really shall remain nameless for now, but I'm sure that has nothing to do with how happy they are with the improvements we're making to the tools, other reasons. And in 15.7 that shipped this week, there is a significant improvement in the way we process PDBs in the context of MSPDB serves. So if you're using /Z capital I or /Z lower I switches, which are really the defaults for our debug and release configuration, when you move to 15.7, you're going to see this type of benefits. Of course, your mileage may vary, but these are kind of the benefits this huge code bases have seen when they move to this version. What's even more exciting, it's not full build. It's incremental build. It's the thing that you do every day when you change a few files and you hit F5 and you can't wait to get to your breakpoints. What happens here is that combining those PDB improvements with the improvements that I was mentioning earlier in Debug FastLink, we can actually speed up even more the Debug FastLink scenario. So if you remember, when you didn't have Debug FastLink on, to turn it on, you got a 4x improvement. Now, with it on, if you move to 2017, 15.7, you get another 2 to 4x performance improvement in your incremental building. Now, I should mention, though, that we worked closely with this AAA game engines, and we did further improvements to their build processes by also changing some of the switches. So we're not really comparing apples to apples. There is a part of it that everyone gets for free. And there's additional tweaks that we made to their build processes to actually get an extra boost in performance. But what we did is document all those changes. And if you go to aka.msbc throughput, you get a lot more guidance of how you can take some of the benefits as well. So I do recommend checking out this. All right, and now I think we're ready to talk about productivity some more. And what better way to do that than with a demo? So let's go back to my computer over here. Not minimize that. So this demo picks up exactly where my demo last year at Build in the session with the same name left off. So I used the OpenTDD game to demo a lot of the code navigation and IntelliSense improvements we made in 2017. All those features are still in there, and they're awesome, and they rock. So you should use them day to day. And I ended the demo with the announcement that we're integrating Google Test inside the Test Explorer, and I ran a test, and that was the wrap of the demo. So since then, you've seen we did a lot of progress with unit testing. So you've seen the code lengths and the support for Google Test and Boost Test popping up in CMake scenarios. We added Boost Test as well as a supported scenario. And now, in this demo, I'm in the process of migrating from Google Test to Boost Test, my test, for no good reason other than show you that Visual Studio supports both of them, and it's not gonna have any opinion about what you should be using. So if you go back, tomorrow and start changing your unit test framework that the team uses, Visual Studio will be able to run both. Your team may have some objections to that, but as you can see here, Visual Studio runs all of them in no problem and in the same session, really. So let me open this file over here. And what you see is, again, the code length view of every test that I run directly into my editor. So I can go over here, and I can see the details. I can run or debug these tests. That is pretty cool. I don't even need Test Explorer now. But there's more things to show in here. And there are some green squiggles that pop up over there that are new, probably not used to them. Now, I'll say that for the purposes of this demo, the density of this green squiggles have been increased. But I promise you that these squiggles are coming to a code base near you pretty soon. So this is something that we're working on in 15.8. And what this does is run code analysis in the background for the files that you haven't opened in the editor. And it brings in that information of all the security analysis we do, code correctness, and all the core checks that we do for your C++ core guidelines support. Brings it inside the editor so that it helps you with the files that you can actually make a difference, rather than going to the build process and building all your files, all your project with static analysis, and getting a slew of errors, a slew of warnings that you don't plan to tackle because those are not the files that you plan to edit. These are the files that you can make a difference, and I hope you will. It's an opportunity. It's not a challenge. So these are the things you're going to see, for example, that a member was missed and it wasn't initialized, that arithmetic overflow happened in that operation, or that you can actually turn this into a const expert rather than const, because everything is const experting. And look, it actually has a fixit. That's the only fixit I have for static analysis today. But this is something that we're going to continue working on. So you're going to see more and more popping up. Basically, const expert all the things. That's something that we're after. And then for this one, well, there's always going to be some static analysis warnings that we're never going to be able to fix. You really need to go back and tell us, what were you thinking in writing that code? So, so for this one, let's say I want to fix it. And to refresh the static analysis, you do run code analysis on file. This will just run code analysis, and it will refresh the status as soon as possible. It's going to be a background run, but it's still on demand. All right, so let's move on to the next test. Let's see if this test actually passes now. So I can click Run over here. And I can move to the next test. Now, the next test uses a lot more macros. So that's not nice. And it fails. Let's see where it fails. I go to the stack trace and click it. I can see that this statement failed. And it's either the result of this macro called sphere volume or the result of that function call. So let's dig deeper into this macro. So control-click now does go to definition. And you can configure it to do go to definition or pick definition. And you can keep going and going. And then you can go back and try to wrap this macro in your head of what actually does. How many times did you do that? So now you don't have to do that anymore because we have expand macro over here. So with a quick of a glance, you just hover the mouse over and you can see the full expanded view of the macro. And it actually makes sense. It's 4 pi cube of radius divided by 3. I think that's right. So now this macro doesn't sound that scary anymore. Doesn't look that scary. So maybe now it's a good opportunity to change it. But to what? What are you going to change it to? Well, const expert all the things, obviously. So that's something we're adding new and in Visual Studio, convert macro to const expr, so we can do it for small macros. You can see here the change. It was going to give me a detailed view of what happened. Or you can do it for macro functions. And you can see turning it into a const expr template. Now, this is not just a text-based operation that we're just adding to Visual Studio. So let's look at this rect area macro over here. And allow me to go down here and write this. Now, any idea what this does? This does something really bad. This declares a pointer to int called p. And yes, that's the kind of power that macros give you. So now if you go here and do convert to macro, what happens is that, oh, well, you're using it incorrectly. This is not an expression. So we'll be able to detect those cases and give you a detailed view of where the offending line is. All right. Moving on. We still haven't figured out why this test fails. And since we're const expr all the things, there's a small parenthesis I want to make. All of the announcement we have about standard conformance that pertain to our compiler and libraries really apply to our language services as well inside the editor. So when we talk about conformance, really, we enable all those features inside your editor as well. So if you hover over this const expr, really, we compute it on the fly for you. And if I go to this definition over here, there's more examples of things that we do for you. Obviously, auto deduction, so it gives you the actual type. But even C++ 17 features like this that save us for typing all the things, we can tell you what the type actually is of this template. Now, everything looks all right with this one, so I'll just go to the main call over here. And this is a template. So I'm starting to get a bit nervous because my companion so far, IntelliSense, I already know that it's not going to be very helpful with templates. This is a template body. There's not much we can do in here. If I hover over begin, yeah, it's an iter. It's correct. If I hover over this one, is a value type. Yeah, that's correct. If I hover over it, it's an auto. Yeah, thank you. This is great. Very useful. Wouldn't it be nice if we could actually look at how the compiler looks at this template? I know what you're going to tell me, that compiler doesn't look at this template. It doesn't even compile it. Well, it does if you instantiate it, right? So can we look through the eyes of the compiler to this template here by using the instantiation? And because I'm bad at typing, I'm just going to copy this one, which is the actual instantiation, if you look at the tooltip, of this particular function template. And I'm going to go over here in this new tooltip, and I can provide sample template arguments for IntelliSense. Let me paste it over here. And now let's see what I get. If I hover over begin, look, it's a std vector. And if I hover over this value type, this type def is actually a vehicle order. It's not a type def. It actually makes sense. If I hover over input begin, I get details. And if I hover over an auto, again, just like before. But now I'm in a template, but I get the actual type of the template. And even more, if I hover over the operators, I get the operator overload for this particular case. It tells me exactly what function is being called. But wait, there's more. Have you ever seen IntelliSense member list showing up in here? All right. So this is something that we're adding in 15.8. I hope you're excited. I feel like we're adding a superpower to IntelliSense. And we need your help, we need your feedback to actually keep improving this and making it production quality until we actually ship the RTW release for 15.8. So in summary, I showed you a lot of productivity features. I showed you how you can bring a modernization angle to your code base by adding new code analysis squiggles in the editor, turning macros into const expr if you need to. I showed you how IntelliSense helps you with understanding C++ 17 features inside the editor. And at the end, I showed you how IntelliSense can handle template bodies now. So I hope I got you all excited, and you will download the latest releases as soon as possible. Obviously, as I mentioned, I haven't covered all the features in this demo. There's a much longer list of productivity features inside Visual Studio. For example, the state function debugging. That's an improvement we made in debugging that allows you to step directly into your code rather than having to kind of step over all the glue code that the standard library has to have for a state function. Another example is ImageWatch, which is an extension that you must have if you're doing OpenCV or any other image manipulation libraries that you're using inside your debugging. This gives you a preview of how the image actually looks like in the memory of the process you're debugging. All right? So I like to leave last a reason that I always, it's the hidden reason that you should all be using. I like to talk about it because I'm basically in awe of the amount of passion that many of you bring to the conversations that we have on user voice for suggestions and on developer community for reporting a problem. And it gives us great satisfaction that we're able to solve so many of the issues that you're reporting. These are kind of the stats to date since we started work on 2017. So for everyone that ever reported an issue, I want to give you a big thank you. And please keep that feedback coming. And we're going to summarize really quickly in conclusion. So regardless of the build system you're using, regardless of the unit test frameworks, the C++ libraries you depend on, in the spirit of really our vision to bring VS to any developer, any app, any platform, we think that Visual Studio 2017 is the one IDE that gives you the best C++ development experience. With that, I want to thank you for coming today. Happy coding.